reliable LLM applications isn't just about picking the right model anymore. In fact, once you move beyond prototypes and start building something in production, the real challenge becomes managing the data and the iteration loop around the model. You need to capture real interactions, turn them into structured datasets, improve the model responses over time, run multiple experiments with your LLMs, and eventually fine-tune the model with the better versions of the system. But in practice, this process can often be very messy. Teams end up juggling CSV files, having to manage ad hoc scripts, scattered experiment outputs, and multiple disconnected tools just to manage their training data. And that's exactly the problem that we're going to address in this particular video. Today, we'll be showing you how you can build a fine-tuned customer support assistant. And along the way, we'll explore how the Nebius Token Factory Data Lab helps you to structure this entire LLM data lifecycle. Instead of having to manually manage the prompts, the responses, and the datasets, Data Lab provides you a unified environment where you can store your model interactions, generate improved responses using larger models, curate datasets, run batch jobs, and connect everything directly to your fine-tuning and deployment workflows. So in this tutorial, we'll start with some raw customer support prompts, generate improved responses using a stronger model, convert those interactions into a dataset, fine-tune the smaller model on the curated data, and finally deploy the result as a custom model. So by the end of the video, you'll understand how to build a repeatable pipeline for your LLM post-training workflows with the proper data management and model deployment, all with the help of a single platform. So let's get started. So first of all, what exactly is the Nebius Token Factory? All-in-one platform which allows you to leverage different types of open source models with the help of these endpoints. So for example, the NVIDIA Nemotron 3 model was just launched, and here you can see an OpenAI compatible API where you change the base URL to Token Factory, you generate an Nebius API key that you can use, and now you just use the built-in method for charge completion and just specify the NVIDIA Nemotron model which is coming from Nebius. And you have multitude of different models to choose from, including most of the popular open source models, with an interactive playground as well where you can test and compare between the different types of models and their responses to select the most appropriate model. But in addition to this, you also have the capability to do post-training, which means you can run fine-tuning jobs. In case you're not happy with the output of the base model, you can upload your own custom datasets and run fine-tune models that you can then also go ahead and deploy. For example, if you have a load adapter, you can deploy that as a custom endpoint with the help of a base model. And at the fulcrum of everything is the Data Lab. So the Data Lab allows you to create and explore and manage all of your datasets in one single place. So for example, if you were generating responses with the inference API and you want to use those outputs of those particular responses to fine-tune the model, you can just go ahead and import completions API. So this will import data from your chat completions, and it will be used as your input source for training or fine-tuning your model. So here's an example of the inference logs that I ran for about a month's time, and you'll be able to see all of the prompts, the completion. So now you could use this and curate your well-structured input-output queries that will be used for fine-tuning. And you can also upload your own custom dataset that could be used for your fine-tuning workflow. So it's a great tool for managing everything, including batch jobs and managing your inputs. And here you can take a look at all of the completion operations that have run. So here we have import completions, but if you're doing batch inferencing, all of these operations can also be shown at one single platform. So you don't have to manage multiple scripts trying to do all these things at the same time. All of them will be shown in a single platform. So let's go into looking at what exactly are we going to build. So we are building a custom fine-tuned customer support chatbot with this 8-step process. So imagine that you're trying to build an e-commerce store and you have a customer support chatbot. And right now, the responses that are being generated from the model are not that great. They are pretty average, and you want to improve the model performance. So one of the ways is you will be fine-tuning the model. So here in this 8-step process, what we're doing is imagine that you had a preset of these unoptimized, really bad responses. So that's what we are trying to generate, because we are just trying to emulate that particular experience. So for that, we'll just generate some basic logs with a preset type of questions. We'll just generate some basic logs with the help of the Nebius baseline 8 billion parameter model, in this case Llama model, and these will serve as our baseline dataset that contains the unoptimized responses. Now what we do is that we upload our raw dataset to Data Lab, and we use batch inferencing with the help of a larger, much more well-suited model to generate high-quality responses, which will simulate what we actually want in our production application. And now what we do is that we download the raw dataset, including the batch responses that we got from our larger model, and we filter out the appropriate replies, and we build the JSON lines dataset for our fine tuning. And all of these operations are happening within the Nebius Data Lab with the help of the specific APIs, or you can also do that equally on the UI side of things as well. And now this is where we come into our token factory post training. So we've collected our dataset and our high quality responses from our larger model. So we help curate our file, which will be used for our fine tuning, and we upload that file. And now we go ahead and fine tune our smaller student model with the LoRa adapter. So it'll allow us, or the LoRa job, and we'll create the LoRa adapter files. Then we will take our base model with the LoRa adapter files and deploy our custom private model. So here you can take a look as an example of how the custom private model looks like. So here we have a private endpoint with the fine-tuned model, which I did as a previous experiment, which I'll also be showing. And now we can go ahead and smoke test to take a look at, okay, what's the performance like for our entire model? So this entire 8-step process basically shows us going from really low quality outputs to then getting enriched responses from a higher or a much bigger model, and then using that data set to fine tune our model so that it can start to get much better responses, and then running that as well. So we have this Jupyter notebook that will go step by step into explaining this entire fine tuning process with the help of the data lab. So let's go ahead and take a look. So we have our teacher model, which is a stronger model for writing the better answers. And this is where essentially we are using distillation, which will allow us to use the teacher's answers to create a better training data set. And we'll be fine tuning the small model so that it can behave like the support bot that we want. So initially, we just went ahead and ran some of the commands first, including getting our Nebius API key that you can get from the Nebius Token Factory dashboard. And once that is done, this is our entire control panel of all of our notebook. So the first things first, you can see that we have the API key that we are fetching. We have the base URL set here, which is api.tokenfactory.nebius.com. We have our URL here, and this is where we have defined our teacher model. So this is the larger model that will be used for curating the higher quality responses, and this is the specific model that we'll be using for fine tuning our base model. And then we have some additional parameters. So these are the specific things related to, okay, like what is the LoRa rank and total number of epochs, so the training cycles that we'll be running, and where exactly we would like to keep our data lab folder. And then we have some of our input prompts. So this is the support system prompt that you're a helpful support assistant, and then we have some domain specific topics that we'll be using for generating the responses. And finally, we will just go ahead and run this. So as we run this, you can see that we have a total of prompts in demo set, which is 10, and these are all of the relevant artifacts that we'll be using. Now we have a certain set of helper functions that will allow us run our entire workflow, and this allows us to extract the responses that we get from the larger model and then use that to create our fine-tuned dataset that will be used for running the actual fine-tuning. And here you can see that we have different steps and the functions related to that. So the first step is to generate just the baseline logs. So here we'll provide the set of input queries and generate like the baseline logs. So this kind of replicates, as I mentioned, your really unoptimized responses. But then what we're doing is, the next step is we are uploading our raw dataset. So this is where we are uploading the raw dataset to Data Lab. So here you can see that in order to upload it, we have the function as v1/datasets, and this will allow us to upload this particular raw dataset over here, and we have given the name of the dataset as customer support raw and the specific UUID attached to it. And the next step is that we will now, since we have uploaded our raw dataset, we will actually go ahead and run a batch inference job, which will allow us to use the larger model and get much more well curated responses. So in this case, you can see that we have the payload where we have mentioned the type as batch inference. We provide our source dataset ID, the version, and we also provide things such as what the model we are going to use. In this case, we have the teacher model with the completion window as the batch completion. So going back, now you can see that as we move forward, we will go ahead and also create an operation ID. So here you can take a look inside of Data Lab. We have operations, and when we run a batch inference operation, we have to define the type of the operation. So here, that is why we have this defined. We have defined the dataset, and now we just go ahead and run our batch processing, and we keep a poll. So this will tell us at every few seconds what's the current status, and the status can be either succeeded, failed, cancelled. And then the next step would be to download and generate the responses that we got from, or the responses that we got from our batch inferencing. We'll just curate that, and we'll basically go ahead and create a very well structured curated dataset that we are now going to use. So once you have created that JSON lines data, we go ahead and upload that data to do the fine tuning. And finally, we go ahead and launch the fine tuning with the help of this client.finetuning.jobs.create. And we finally go ahead and deploy the LoRa. So we'll go back to this particular function in just a while. So let's go ahead and take a look at our step one. So step one was to generate our baseline logs. So we just go ahead and run that. So for that, we'll also ensure that we run this particular cell. And now we will go ahead and generate our baseline logs. So let's just wait for it to do that. So here you can see that it has started to generate the raw baseline logs. These, you can think of them as emulating like the most basic type of architecture. So all the responses have been generated. Now what we'll do is we'll upload this data to our data lab. All right, so it has been uploaded to data lab. Now we'll go ahead and run our batch inferencing with the help of the stronger teacher model. Let's go ahead and do that. So here you can see that this is the output dataset ID. So if you go back to our data lab and just refresh, we should be able to see a new data lab batch inference ID that you can see here. It has been queued, and also there should be a new dataset that we have just uploaded, which is this customer support raw dataset that was uploaded by running the raw inference. And now we'll just wait for this batch inferencing to complete. So once the entire batch status has been completed, what we can do is we will go ahead and download that dataset. We'll in the input, and you can take a look at the batch dataset that we got created here. So this is the entire batch response that gets generated after you have successfully completed it, which will basically show up in the operation. So this is the output file that gets generated, which is seen over here. What we're doing is next we are going to clean that particular data, and once that has been cleaned, the next step is to basically upload the curated file that will be used for the post training. And that is what we'll do in the next step, in the step 5, where we are going to go ahead and upload this training dataset. And next step is that we'll go ahead and fine tune the model. So let's also take a look at the function that is actually going to do the fine tuning for us. So here you can see that we upload our training dataset that has been curated, and next step is to launch the fine tuning. So here we have client.finetuning.jobs.create, which will help us to create the fine tuning job with the training file ID that we have uploaded to our via the files API. So here you can see that it's client.files.create. So we're using the files API. We're providing our hyperparameters here, including the total number of epochs that we have defined at the start, which means what type of lower alpha, all these particular values. And then we'll again, as we run this, we'll be able to take a look at what's the current status of our fine tuning job. And all of the fine tuning jobs will come under the post training here. So for example, this was the fine tuning job that ran. This is the dataset that we created, which is the curated dataset, and the checkpoints that also get downloaded. So after each and every epoch, you'll be able to download the checkpoints. And once the entire fine-tuning job completes, you get a list of all of these different files, which are the LoRa files, which are needed, including adapter.safetensors. All these are required for the LoRa adapter. And once you have fine-tuned, the next step is to actually go ahead and deploy your LoRa model. So what essentially is happening here is that you take your base model, which was frozen, and you also get your LoRa adapter files, and then you pass them. So when you're actually fine tuning, you freeze the base model and you apply the additional layers on top of it, which have the fine tuned data. And this is how you're actually able to get your fine tuned model. So here what we're doing is we are getting our base model, and then in addition to that, we are going to, and for that we have the request as v0/models, and then we append to it our LoRa adapter files. So here you'll be getting your base model plus the LoRa files, and we'll deploy that as a private endpoint. And that's what is essentially happening in this particular function. So when it comes to deploying the model, our next step is step number 7, where we are getting our deployed model. So here we are getting the LoRa adapter, and then we get our base model, and then we use the deployed model. So here we get the state, what is the new deployed model using that particular adapter, and this would look something like this. So once the entire fine-tuning job has been completed, in fact, if you don't want to use a code, you can also actually click on start deploying model directly here from the UI, where you choose what is the base model, what name do you want to give to the LoRa adapter, give the description, and click on the deployment. And as soon as you go ahead and do that, if you go back to your Explore page, you'll be able to see the private endpoints. So this is the example of the model that we were able to fine tune. And here you can see that the model that it's using is for customer support. So this is the fine tuned model with the base model and the LoRa adapter that we got after we ran that particular fine tuning job. And we can now start to use this particular model just to replace the model name with our fine-tuned model and start to build our application. And we can also run some smoke tests to quickly take a look at what is the response quality of the entire model. And here you can take a look at what the smoke script actually looks like. So let's go back to our list of functionalities here. So we have the smoke test. So we have given it some test prompts, and it will go ahead and generate a response based on these test prompts. Now actually let's take a look at how this looks like from a front-end perspective. So here I'll just quickly give some credentials, and it will take us to our chat application. So here you can see this chat app that is being powered by the Nebius token factory model. And what I've done is in my backend, we are using this private deployed model that is already here present for us. So the model is this one, and we are using the rest, everything is the same. So let's go ahead and test this out. So since we have trained it on specific data that has been curated for this particular e-commerce store, so let's say I ask it, what is the return policy? Give me strictly the policy. Then let's see what it generates. So rather than giving us a very vague answer, it tells us that the returns can only be made within 30 days of delivery, which is an information that has been, we have been able to fine tune the model with the specific data about this particular e-commerce store and things related to, let's say, the orders or even the return policies. So this way we get a much more well curated response, and which is a lot more accurate by following this 8-step architecture where we are using the Nebius Data Lab for managing everything related to your data sets, to the versioning, to all of the responses that were generated from our teacher model. We were able to use those and leverage those in order to generate our fine-tuning training data, and then we were able to fine-tune our model and deploy it as a private endpoint. If you want, as I mentioned earlier, that you can also deploy it as a standalone dedicated endpoint as well, for which you get dedicated GPU access, so you have full-fledged support for running much more larger scale workloads with this deploy dedicated endpoint. Yeah, this was a quick overview of how the Nebius Data Lab really helps with managing everything end-to-end, managing your data sets, batch inferencing, and fine-tuning workflows. Everything can be managed with just one single platform without having to run a lot of ad hoc queries, ad hoc scripts that make it a lot more difficult to manage your data for the fine-tuning job. So now you can just focus on ensuring that your fine-tuning model is actually good enough, and if you're trying to do a lot of experiments where you're tweaking the fine-tuning parameters, because there will be a lot of them involved, all of that can then be managed fairly easily because you have all of your data sets, your inference logs, everything under a single place. So that's a quick tutorial. Thank you so much, and stay tuned for more such tutorials as well.